Next topic, applying Java AtomicLong. So we've shown how to implement Java AtomicLong. We showed it with the unsafe class, but we could have done it with var handles for that matter. But irrespective of whether we use var handles or we use the unsafe class, let's see how you might actually use this thing in practice. And this is a really, really funky and interesting example that actually comes straight out of the Java class library. And so we're going to see how to implement some of the code in the random class that Java provides. So the Java random class, you probably know what the random class does. It's used to generate pseudo-random numbers. So there's ways of being able to generate the next random int or the next random long or whatever. And in order to be random, we need to seed the random number generator with a random seed value. And the idea here is to try to get the thing to be as unique as we possibly can. And you'll see that the way it does that is by taking the current time on the system and using that as part of the seed. So there's a default constructor. If you say, new random and make a new random object, which is what you typically do, this will go ahead and create a random seed based on a computed value that's XORed with the current time of day. So you can see here that there's a method called seed Uniquifier, and we take that and we XOR it with the current time of day. All right, so let's take a look and see how this all works. Now, the seed Uniquifier is given an initial value that's just a very large, long value. So that's the seed Uniquifier. Okay, fine. This method, seed Uniquifier, is a factor method that automatically generates the next unique seed value. And this is really, really funky and crazy, but it's interesting. Now, as you'll see, this code here runs in a for loop. And we'll talk about why in a second. And then it has to do with the fact that we do an atomic read here and then an atomic compare and swap here. And we need to try to make sure that we keep looping as long as the value we got back here changes between where we set it and where we try to do where we set it unilaterally using or reading it from the get call, storing it in S, and then when we do a compare and set down here, we need to make sure that nothing has changed. So let's say, just for sake of argument, that we have 4 threads in our system, all of which happen to create random numbers, and therefore seed Uniquifier is being called 4 times in 4 separate threads on 4 separate cores, all at exactly the same time. So, this is a little bit unusual, but certainly not impossible. So you could have 4 threads that are all creating a random number for the first time. They all end up calling seed Uniquifier, and seed Uniquifier will get the value and store it here. And so 4 threads all call get. So they're all going to get this value here. But we want to make sure we have a unique value that's stored. So what we do then is we create a potential next seed value by taking the current value and multiplying it by some other very large long value. Not sure where they came up with those values, by the way, but they're just big, long values. And then we try to compute the next seed atomically. And this will succeed only if S is still the current seed value. So we're using compare and set here. And this value will be updated to next only if S has not changed since we read its value there. And what we're going to do is, if we were able to atomically make that change, we return the new value. Otherwise, we are going to loop back around again and keep trying until we can atomically change it to the appropriate value. So you can see here that if for some reason we are not able to get a unique value because somebody snuck in after we read this value and they computed something and changed it, we are going to keep looping until we finally get it changed atomically. So why are we doing this? If we didn't do it this way, if we didn't do it this particular way, we could end up with having multiple threads on multiple cores creating seeds that are non-unique. And we're trying to create unique seeds. So if we did the code like this, notice what's happening here. We're reading the value and setting the value. It could turn out that between the point when one thread read the value and went to set it, another thread could have come along and read it and set it as well. And so we might not end up with atomic seeds that are unique. But doing it this way with the loop and compare and set guarantees unique seeds, which is important because we're trying to make sure that the random number generators are going to generate random numbers as uniquely as they possibly can. And if they all end up with the same seed value, they're not going to be unique or as unique. Because once the seed value is set, then that's what's used as the basis for all the other random number random numbers that are generated. Now, in Java 8, they have this really cool feature that's called update and get. And even that particular approach will still not be sufficient to do what we want. So we really need to use the loop approach, the approach that we saw here. We really need to run this in a loop using compare and set. Okay, so that's an example of applying AtomicLong. Very sophisticated, right out of the Java virtual machine class library implementation, rather, the class library implementation of the random class in Java. And you can see that somebody spent a lot of time thinking this through and implementing it carefully to try to make sure that the seeds, so the random numbers, are as unique as they possibly can be.